So, this particular lecture will focus on data center networks, which is a very important concept, a very important technology that is required for building large scale industrial Internet of Things. In the previous lectures, I already highlighted the need for analytics. The data will have to be managed properly, will have to be analyzed thereafter. We have also seen that the data that we talk about in industry scale for IIoT scenarios, this kind of data has the properties of big data, which have different challenges of its own. These are typically unstructured data having different characteristics of 3 V's through 5 V's through 7 V's, and this is what we have gone through in detail in the previous lectures. So, without getting into the characteristics of big data further, the question is that how do you handle the data? So, from an analytics point of view, we have already seen that what are the different methodologies, what are the different tools and techniques that could be adopted in order to handle this kind of data. But where do you store the data? Where do you process the data? That is very important. And if we are talking about large scale implementations, we have to talk beyond single servers, low capacity servers. We have to talk about large scale, not singular servers, but servers, server farms, connection of different servers and so on, and this is known as the data center network. So, in a typical data center, what is a data center? Data center is basically a facility which has lot of high capacity computational facilities of all kinds, high capacity, high performing computational systems having high end processors, high end storage, high end memory, and also high end computational or network facilities. So, everything has to be high end, but that gives you a data center only. A single data center is often not enough to cater to the requirements of most of the real life industrial IoT scenarios, in which case a network of data centers would be required. So, this is what we are going to talk about in this particular lecture. So, we are going to try to connect, to try to understand the requirement of data center networks and how they bridge the gap between the origination of the data and the analysis of the data. So, analysis comes next, but then how do you handle the data that is coming? So, you have to store the data, you have to process the data in these data centers and the data center networks, and that is what we are going to talk about here. So, what is a data center? As I was telling you earlier, here we are talking about high end computational facility which are networked computers, network servers, high end servers which are networked together, and also network storage. Most of these large scale enterprises, their information systems are highly dependent on these data centers. It is these data centers, as this name suggests, which stores all this data. Here there are different examples of data centers. Data centers are quite widely available. Large scale companies such as Google, Amazon, Cisco, they have their own data centers. Others rent the data center facilities and so on. There are many other companies which also have their own data centers, and maintaining the data centers is a different topic by itself, right. So, we will not get into that, but let us try to understand beyond what is a data center. So, here in this particular lecture, we are not talking about a single data center, we are talking about a network of data center, because that is what is more relevant and that is more used in the IIoT contexts. So, in a data center network, basically we have all these different data center resources involving computational storage and network entities which interconnect with one another. So, different data centers will be connected to one another, and that will help in different ways, including handling the varying data loads that are going to come over time. So, handling that kind of thing, data loads and computational loads that are going to come over time, that can be handled, load balanced in a proper manner if you have these networked interconnected data centers. So, before we go any further, let me just show you pictorially how a data center looks like. So, in a typical data center, so I am going to show you the architecture of a data center. So, in a typical data center, we are talking about what? In a typical data center, we are talking about a single platform of different computational resources and servers, etc., a network of servers, not a network of servers, but an interconnected platform of servers and so on. And in a data center network, what we are talking about? We are talking about these kind of data centers which are internet worked together, right. So, let us talk about these data center networks and how they look like schematically. Let us talk about that. So, in a typical data center, we will have let us say that different servers, server 1, server 2 to let us say server n, right. So, this is one edge device, which could be like connected through some kind of a switch, right. So, we are talking about these kind of different servers which are placed together. So, this forms something known as a rack. So, let us say that this is rack 1. Every rack has something known as a TOR switch. It is basically a switch which will help these different individual servers in a rack to be interconnected together, and also it has different other management and maintenance capabilities. So, this is like a switch, and this is known as TOR, means top of rack. So, we have every rack having a switch and is controlled, it controls basically number of different servers. So, we have one TOR, we have another rack with another TOR, server 1, server 2 to server n. So, whatever be the n, right. So, n may be equal to 5, 6, 10 or whatever depending on the type of rack. Like this, we will have other such edge devices in a data center. So, we will have these different TORs and with different servers, and this will be rack n, right, rack 2, rack 3, rack 4 and rack n. So, we will have all of these. So, then what we are going to have is the next layer over here in a data center network will be some kind of an aggregator. This aggregator is another switch which is going to aggregate these different rack devices. This is another aggregator. So, this was the edge layer, this was the edge layer. Here you have the aggregator layer, layer, and so like this you have all of these different aggregators. Then you have the core layer, where you have core level switches. This is core 1, core 2 and so on. These are all core level switches which basically again aggregates at a higher level. So, these core level switches are even more powerful switches, and then you have these core switches connect to the internet. So, this is basically a typical data center network architecture, how it is how it looks like. So, core basically will be something like 10 gigabit switches will support this core. Here also you are going to have at the aggregator level also you can have something like 10 GB switches, whereas in the edge you may have lesser like 1 GB or it can be even 10 GB depending on the resources that are available and the particular requirements of the client. So, this is a typical data center network, how it looks like, right. So, let us now go ahead and go further and look at the different characteristics of these data centers. So, on the right hand side what you see over here in this particular picture is a picture of a data center network, right. So, it is a network, it is a data center network picture, and here as you will notice these are like different servers showing these different green lights. These are these different servers that you have like this, there are different servers. Each of these, this is one rack, this is one rack, like that you have different other racks like this. Each rack has its own TOR. So, they have their own different TOR and so on, right. So, if you want to get a little bit more idea about what is a data center and how it looks like in real life, etc., etc., there are plenty of videos that are available if you search in the internet. There are two different references that I have given you over here of a Google data center, how it looks like. So, this particular reference will help you to understand the Google data center, what is inside, So, they have their own videos. I am not going to play it, but Google data center and its link is given in this particular slide. So, let us go further and try to have a look at the different properties of these data center networks. I am not going to elaborate all of these because this is something that you will understand on your own. So, basically these are some of these desirable properties of the data center networks. A data center network has to be stable, secure, reliable, should support different network requirements, should be scalable and should be agile. So, out of all of these which are pretty much easily understood, agility is something that I would like to briefly mention. Agility property means that a data center network should be able to provide any kind of service on any server at any time. This is known as the agility property of a DCN, and the other properties, as I said, are easily understood and I do not need to elaborate further. So, data center networks have their own individual requirements. VM migration without changing IP address should be supported. This is very important. Without changing the IP address, VM migration. VM is the virtual machine. So, basically to the end user gets a virtual machine and is mapped to a particular physical machine having its own separate IP. So, the end user has its own virtual machine which has its own IP. So, even if the physical machine to which it connects to changes its IP, that means it changes its machine, still to the end user this particular virtual machine and the corresponding IP address that it has got is not going to change. So, basically this IP address does not change in the case of the VM migration in the case of data center networks. Second requirement is that there should not be any need to configure switch before deployment, right. So, you deploy the servers first, then you deploy the switches and thereafter you expand this particular thing further. So, you scale it up further. So, servers, switch and you scale up further. Say third requirement is that paths should be available among the end users to communicate. End users should have different paths in the data center network which will help them to communicate between different instances, between different different users and so on. So, basically it has to be fully networked. In other words, it has to be fully networked. This is very important. Fully networked means then only you would be able to have different paths as per the dynamic requirements that are that come up. The third, the fourth and the fifth properties are quite understood. So, data center networks should be able to detect any kind of failure and should offer efficient repair of failure. So, self healing behavior, that means that the data center network, if anything goes wrong, should be able to heal on its own, should be able to repair the particular component that is there. I mean, whatever has failed or is going to fail should be repaired on its own. That is basically the self healing property of a data center network. A data center network should be as much autonomous as possible, and that is why all these different expectations and requirements are coming up. So, data center networks are huge, you can abstract a data center network like a huge computational resource which has huge processing, huge storage, huge computational resources, which can be offered to end users as per requirements and so on. And so, they have to be fully autonomous, they have to repair on their own, and whenever there is some kind of failure, the detection of the failure should also be done by this particular autonomous data center network system. There are different applications of data centers, serving outward facing applications such as serving web pages to users, through internal computational applications such as use of MapReduce for web indexing, through running multiple concurrent services, and many more. These are some of these different applications of data center and data center networks. There are different topologies that are supported of a data center network. The common ones are the 3-tier DCN, that means the 3-tier data center network, the fat tree data center network, the D cell and the B cube. These are the 4 different data center network topologies that are available. So, let me talk about some of these. So, we will start with the 3-tier DCN architecture. So, essentially at the outset, when I discussed or when I explained the concept of a DCN, the architecture that I had showed you consisting of different servers in a rack, having Tor, etc., that is basically a 3-tier architecture. So, you have the edge, you have the aggregator layer, and then you have the core. But let us look at it from another viewpoint. So, what we are going to have at the very bottom, what we are going to have are, let us say, different servers, right, different servers. These servers will be interconnected with each other to these devices known as the aggregator device. So, this becomes your aggregation layer, this becomes your Tor. So, servers in a rack, each rack having a Tor. So, let us say that this is the Tor layer, this is the aggregation layer, and then on the top you will have let us say, and this can be even like this and so on, and then you have over here something like this. This becomes another level of aggregation, or in other words, let us do it like this, that let us say that we have all these are like the different individual racks with servers. This is, we can call this aggregation layer at like a Tor layer kind of thing, and this one we can think of another layer up, which is the aggregation layer, which has its own aggregated switches, and then for this one again we will have this core. This is the core, right. So, exactly, I mean, this is something that I had shown you in the at the outset when I talked about the data center network, when I explained to you the architecture, the typical architecture of a data center network. Now, you can basically what you can do, you can have something like this repeated once again, right. So, this becomes one data center, this becomes another data center and so on. So, you can have another like this. So, this is your Tor and these are your different servers. So, then you have like this your aggregator and then you have your core, this is your core. So, this can be like this can be like this, right, and similarly over here as well. Okay. The beauty of a 3-tier DCN would be to have connections of this sort, right. You could also have something like this. And so on. So, this would be possible. So, you are going to have a huge data center network with racks and servers at the very bottom layer, then you have this store layer, then you have this aggregation layer, and then you have this core layer. So, store, aggregation and core, these are the 3 different tiers. So, this becomes your tier 1, tier 2 and tier 3. So, this is how a 3-tier DCN looks like. So, let us go back once again and have a look at the properties of a 3-tier DCN. So, a 3-tier DCN, as we have seen, has a tree based network topology, and there are multiple roots in the tree topology. So, multiple trees with multiple roots networked together. This is your 3-tier DCN. There are these different layers of network switches, core, aggregate and edge, and then there are different disadvantages that are also listed over here. Disadvantages of scalability, fault tolerance, energy efficiency and cross sectional bandwidth. These are some of these different limitations or the disadvantages of the 3-tier DCN. So, we are not going to elaborate on these different disadvantages, rather let us use our time to understand the different other network topologies that are supported in the DCN. So, the next one that we are going to go through is the fat tree DCN. So, let us try to understand this particular fat tree DCN architecture. So, we have in a fat tree we have fat tree DCN architecture. Very quickly I am going to show you what it has. So, it has, you can have a k-array tree architecture in a fat tree architecture. So, k can be any integer, it could be 2, 3, 4 whatever. So, k array. So, it will be 2 array, 3 array, 4 array and so on. So, I am going to show you an example of a 4 array fat tree architecture of DCN. So, in a 4 array fat tree architecture, it will be something like this. So, there are concepts of something known as pods. So, there are different pods. So, let us say that you have these different servers or computers or whatever. So, these are going to be connected to some switches. Let us say that these are your switches. These switches together with your end devices, these computers etc., this one is known as a pod. This is known as a pod. So, this entire thing over here, this is your pod, this is one pod. So, this pod will again be connected to some other switches in this manner. Okay. And again this becomes your aggregation layer, this becomes your edge layer, and finally you will have also the core layer like before, where these are going to connect. So, you are going to have another another pod like this. So, you will have another pod and these are your servers. So, these are the switches, and these are your different servers or computers, etc. So, you will have another pod 1. So, pod 1 also, like before, is going to be connected to other switches in this manner, right, and again it also will be connected to this core. So, this is your core. So, like this is going to continue. Now, what is going to happen is you will have each of these pods and the corresponding switches to which it connects. This will be, let us take up this one. This one will be connected to this core switch, this will be connected to this core switch. Again, this one is going to be connected to this one, it will be connected to this one, and so on and so forth. This is going to happen. And so, what this pod tree or the k array or the 4 array tree does is that it ensures that every switch in this aggregation layer is connected to at least one core in all of these. So, from here to here, again here to here, again here to here, and so on. So, it is very similar to your 3-tier architecture, but here there are certain properties. So, what are these different properties is what we are going to look at. So, in the fat tree DCN, we have a k array fat tree. There are 3 tiers like before, which are basically the edge tier, the aggregation tier, and the core tier. So, the pod which I explained to you earlier, at the edge tier consists of k by 2 square servers. So, k equal to 4. So, 4 by 2 is 2 square servers, that means the 4 servers that I had shown you at each of these different pods. And correspondingly, there are going to be 4 divided by 2, that means 2 4 port switches are going to be there. So, each of these edge switches are going to connect to k by 2 servers, which are basically the 2 servers that I had shown you, and k by 2, that means 4 by 2 equal to 2 aggregation switches. So, 2 servers below and 2 aggregation switches above. Each aggregation switch in turn will be connecting to 2 edge switches and 2 core switches, and that is what we have seen in the previous diagram that I had shown you. And k by 2, that means 2 square core switches, that means 4 core switches, each of which will connect to each of these different k pods. So, this is basically how the concept of the fat tree DCN looks like. It is centered on the concept of these pods, and these properties that I just enumerated just now, these are the properties that will have to be held for a fat tree architecture, which is again a tree based architecture having these 3 different tiers, etc., but there are certain specific constraints that I just mentioned. This enumeration of constraints makes this particular fat tree architecture a specific 3 tier architecture. So, there are different advantages and disadvantages of each of these different architectures. So, let us look further. There is this another architecture which is known as the D cell architecture, which uses a recursively defined structure to interconnect the server. The server is interconnected to several other servers and a mini switch via communication links, and a low level D cell will form a fully connected graph, and there will not be any single point of failure in this kind of architecture. This is the advantage, and also this kind of architecture is fault tolerant. So, let us now look at this D cell architecture, how it looks like. This D cell architecture. In this D cell architecture, as we will see, in this D cell architecture, we will have the concept of something known as the D cell. We will have the concept of the D cell. So, in a D cell, you have something called the mini switch, and every mini switch has a server. This is a server, this is another server. Every server in a D cell will connect to another D cell server, this is another server, this will be another server, which again will be connected by a mini switch. This is another mini switch and this mini switch. This mini switch basically connects to two different servers. Again you are going to have something very similar. You are going to have a mini switch with two different servers like this, and these again will be like this, and this is how basically this DCell architecture will look like if we are talking about two servers only, two servers. You can extend this particular concept. As you can see over here that this is more fault tolerant architecture. Let us say that if this link breaks, and so you will find another path between these servers through which the data can be routed. So, this is a fault tolerant architecture. So, let us say that you take the case of a three server architecture. So, here basically what you are going to have is one mini switch with three different servers. This is your mini switch and three different servers to which it connects. Then you are going to have similarly another mini switch with three different servers like this. So, this is one DCell, this is another DCell. You can have another DCell with another mini switch and three different servers in the likewise manner. So, this will be your another DCell, and you will have a mini switch with three different servers like this, forming another DCell. So, essentially what is going to happen is one server from here is going to connect to another server over here. This server over here may connect to this one over here, this one may connect to this one over here, this one may connect to this one, and this one may connect to this one, and like this will continue. So, as you can see over here, this is again a pretty elegant fault tolerant architecture of a DCN, which is known as the DCell architecture. So, this DCell architecture has different properties. So, these are some of these different properties that I am going to highlight now. So, a DCell basically uses a recursively defined structure to interconnect the server, where the server is interconnected to several other servers and a mini switch via different communication links, and the low level DCLs form a fully connected graph, and there are these fault tolerant architecture that we have seen. So, these are once again these different properties of a DCL DCN architecture. Let us look at the last one, which is known as the B cube architecture. Here in the B cube architecture, I will show you that we have B cube architecture. In a B cube architecture, you have the concepts of something known as the modular data center, MDC, modular data center. So, this modular data center has different B cubes, each of, let us say that these are the different B cubes, and this is one cube. Like that you can have other cubes and so on. So, in the B cube architecture, you have all these different switches, and these will be connected to another level of B cube. Let us say that this is your B cube 0, this will be, let us say, your B cube 0 1, this will, let us say that this is 0 0, this is 0 1, B cube 0 2, and so on. So, you will have another B cube, and so on, and this one will become your B cube 1, and you can even have 1 1, right. So, these are your different switches at this particular level. This becomes your level 1, this becomes your level 0, right. So, these essentially from these mini switches, they are not going to connect to the level 1, but from here these are going to connect, right. So, this is how it is going to happen over here, not to this one, not to this one. So, only it is going to connect to these. This is how your B cube architecture grossly looks like. So, we proceed further and we try to have a look at the different properties of the B cube architecture. It is a server centric approach rather than a switch centric practice, and it places the intelligence on the modular data center that I just showed you and its corresponding servers, provides multiple parallel short paths between any pair of servers, constructs edge disjoint complete graphs, and forms multiple edge disjoint server spanning tree. So, there is a specific type of routing protocol that supports these B cubes, which is known as the BSR, the B cube source routing protocol, which basically helps in routing in this particular B cube architecture. These are some of these highlights of these properties of the B cube architecture that I had drawn and showed you how they look like. So, let us now very quickly let us go through the different other requirements. So, a data center network requires different networking equipments such as routers, switches, modems, supports cabling of LANs, WANs, network interface cabling and so on, has addressing schemes supported, IP addressing schemes supported by IPv4, IPv6 or whatever is required. These are the only two options at present if you are talking about the internet. So, IPv4 or IPv6 based network addressing scheme are supported. Network security protocols, algorithms, firewalls, etc., are already in place in these data center networks. Internet connectivity is offered through optical, wireless or satellite communication. Different challenges of data center networks include scalability challenges. So, if you want to scale up, the issues are not very trivial. You have to deal with large number of different things, and poor server to server connectivity can be a challenge because it heavily bases on fast connectivity between these different distributed servers and distributed D cells, cubes and racks and so on. Static resource assignment is a challenge. So, dynamically you have to assign these different resources as per the availability and the requirements that are coming from these clients. Resource fragmentation, some part of the resource lies in one location, another part of the resource lies in another location. So, the distributed resources will have to be handled properly. Fault tolerance is a challenge. So, if some part of the network goes down, the system as a whole will have to be able to detect that and will have to recover from it. Other challenges are with respect to the data center connecting to the IIoT. IIoT is data centric, security issues are there, privacy issues are there. Availability is very important if we are talking about industrial machinery fitted with different sensors, actuators and so on. High availability of these machinery means that high availability of these different sensors which produce data. So, availability of this data at any time based on the different requirements is very important. Storage of the data is important, and building up the data center network for catering to the requirements of IIoT is very important and is challenging. In the context of data, IIoT generates lot of data, substantial amount of data which will have to be continuously learned from the end user, is obtained from the end user and will have to be made sense out of using different algorithms, intelligent algorithms, machine learning algorithms and so on, and different challenges with respect to the storage of this particular data. The storage could be consumer driven or based on the requirements of the enterprise. So, different data and storage requirements and the challenges are there when we are talking about data center with IIoT. Security issues, I do not need to elaborate further. Security issues are there in any network if you are talking about a data center network, and that too with resource constrained IIoT connections. Here security is a huge issue and will have to be dealt with adequately. Privacy issues are paramount in IIoT. Data, where this data going through and where this data is going and through which different parts of the network it is going through. Depending on that, because this data sometimes will have sensitive data, the privacy of this data are very important. So, privacy of the data, privacy protection in the context of IIoT and its interconnectivity with DCN is an important challenge. Availability of the data, high availability of the data with IIoT will make the connectivity of IIoT with the DCN very important. Taking care of different requirements such as connectivity of innumerable number of devices which are interconnected, then increase in the complexity of security management, impacts due to security challenges, real time business processes, personal data safety, etc., are different challenges with respect to high availability and IIoT in the context of DCN. Storage management is important. Here we are talking about large volumes of data coming from IIoT. How do you store the data in a cost efficient manner is very important. So, data center networks support different bandwidth requirements are there. There could be because it is a network, there could be dynamic changes in the bandwidth pattern, availability of the bandwidth and so on. So, correspondingly the performance of the data center network will also change. And if we are talking about IIoT, IIoT is a fully distributed system, and these different bandwidth requirements coming from the different parts of the system might also change over time. So, catering to these particular requirements are very important. So, lastly I am going to talk about the software defined data center network. In a software defined data center network, we are talking about virtualized data centers, which are basically the physical instances beyond the virtualized instances, the logical instances beyond the physical ones, and how do you interconnect these virtualized instances and cater to the specific requirements is what software defined data center talks about. So, in a software defined network, essentially we are talking about separating out the control plane from the data plane. So, data plane and the control plane traditionally were put together. In a software defined architecture, a software defined data center network, we are talking about separating out the control plane from the data plane, so that you can effectively, efficiently, in a centralized manner, depending on the dynamic requirements, changes in the requirements and so on, you can change the execution of different jobs in the different parts of the data center. So, network virtualization, storage virtualization, server virtualization and so on, these are core to building software defined data centers, and taking care of the business requirements, business logic, these also will have to be taken care of adequately. So, there has to be a separate business logic layer in addition to the network virtualization layer, the storage virtualization layer and the server virtualization layer in a software defined data center. So, it is very important to separate the control and data planes and to cater to the requirements of elasticity, that means dynamically depending on the increase in the requirements, scalability of the requirements and so on, the resources will also be elastically provisioned and made available to the end users. So, agility is a very important property, and this is something that I talked about in the context of the property of a data center in general, data center network in general, and for software data center as well, agility is very important and should be supported. So, catering to agility requirements with respect to supporting any kind of service on any server at any time is a very important requirement of any data center network, and definitely for software defined data center. So, these are some of these different references of data center networks. I would encourage you, if you are interested, to go through at least some of these different references. So, this particular lecture has given you an overview of data center networks and how it positions itself with respect to IIoT. What are the different challenges of data center networks, particularly when you are talking about in the context of IIoT and so on, is what we have discussed. We have also discussed in detail the different architectures that are available for data center network and how you are going to use them. So, this particular lecture focused on getting some overview of data center networks and their corresponding architectures and challenges and so on. And this we have to keep in mind that this particular high level understanding of data center networks will help us to also build IIoT systems holistically for catering to the specific requirements of the industry segment that this particular IIoT that you are building, the system that you are building is going to support. Thank you.